Hi, just thought I'd put together a little bit of a video or two or three or four about some of the drawings we do here at school. So I'll just jump straight into this one. We're looking at drawing all of these parts for this single sheave pulley. As you can see on this page I've scanned here, it's out of Engineering Drawing, which is the 6th edition by A.W. Boundy. And as you can see, it's on page 239. Okay, all of these drawings, they're in third angle projection. That little symbol tells me that. And we've got a range of different parts that need to be put together. Some of them are sub-assemblies. This thrust bearing, it's a sub-assembly. We'll draw each of the individual parts and put it together as a sub-assembly. This spacer is also a sub-assembly, as is this sheave, which is like a big pulley. The first part we're going to draw is this cheek plate. It's probably one of the easiest parts on that page to draw. So that's where I'm going to start with my students. I'm going to bump the size up a little bit here so we can have a bit better of a look at it. Okay. Before we start drawing any of these things, we need to inspect them, have a good look at what's involved in drawing them, and come up with a bit of a plan on how to draw them. This has a center line. So I'm looking at all of these holes. The center line that runs across horizontally tells me all of those holes have the same center line, and then vertically, these three also have the same center line. Cool, interesting. I'm thinking I'm going to start with this 30mm diameter hole. Then I might put in these three around it and finish off with this 22.5mm hole. Once I have those, I'm going to sketch in the basic shape around it, fillet the corners, and then position the centers on those points. As you can see, that fillet is centered on this circle, this one, this circle, and so on all the way around. Okay, so what are we drawing it in? Just minimize that one. We're going to draw it in Inventor. In Inventor, when we start a new thing like this, I need to set up a new project folder. Okay, this is just on the other screen. Bring it over. To set up a new project folder, you say no. I'm the only person that needs to access it, so we'll just go a single user. The project name goes up here. This is where it's going to store it, so make sure it's going somewhere where you can access it easily. I like to put a 19 on the front so I know what year. Can sort of file them a bit better that way. And this is my demo. A demo sheave pulley. I'm just going to demo sheave. That'll be plenty enough. Okay, finish. And okay, so it has created a the new folder there for it. I know I'm working that one because it has the tick against it. All right. Now to get drawing this thing, we go to new. Again, that's going to be on the other screen. Bring that over. Here we are. Okay, templates. I need to be working in a metric template. Being in Australia, we work in metric. So I'm drawing a part to start with, and I used to want to use the standard millimeter IPT, just means Inventor part file. I'll click on that one, and away we go. So that's opening up my drawing space. My drawing space is a three-dimensional area, and it has three main planes in it. If you want to think of it as a front, top, and a side, if I turn them around this way, this would be my front plane, this would be a right side plane, and this would be a top or a bottom plane. Okay, so I need to choose which plane I want to draw it on. This front plane would be pretty handy. Now, like I was saying, I'm going to draw the circles and then line up all of the centers. The first circle, all right, right in the middle here, this one's going to be 30mm in diameter. So when I look back at, let's pop this up, that's this circle here. So I've just put that one in at 30, and I've used my planes. So basically the very center of that is sitting at 0, 0. It's a known place, and everything needs to be referred back to that. If it can't refer itself back to there, or constrain itself back to there, the line will be green, meaning it can be moved, it's not locked in. My goal is to have all the lines in a dark blue or purple color so that they are locked in and constrained and can't get moved around randomly. Right, so there's that one. Now I'm going to pop in these three. I'm going to put them in randomly to start with. So circle out here. The size of it is, I think, 13.5 millimeters. I've done that wrong. Look at that. Oh no, I got it right. 13.5. So there's one. There's another one that sits out here somewhere. I'm not even going to try and give it a dimension to start with, nor that one. Instead, I'm going to say this circle, put its dimension, has to match that one. See, D1 locks it in, 13.5. This circle needs a dimension. Make sure it's that one there and lock it in. That way, if I ever need to change all three of those, because they're the same, if you look back on the original, it says 3 holes at 13.5. I change that one, it'll change all three of them for me. Now to start to constrain these things. I said all three of these have to have the same center. In my constraints, this horizontal constraint will allow me to say the center of this circle must align with the center of that circle. So they're now constrained. If I go back from this one to this one, I was going to lock them up on that same line. Now, if I change to a vertical constraint, this must line up with this. And there we go. So they're all lining up. They haven't turned purple yet because I can still move that circle if I get a center point anywhere along that line. The center is lined up, but the distance isn't determined. So to determine that distance, looking back, that needs to be 100 excuse me, 180 millimeters. All right, it's locked up, it's gone purple. Same deal again, here to here, this also needs to be 180 millimeters. So I'm going to share that dimension again. Likewise, down here, this dimension, so I'm just clicking the centers, 180 millimeters. All right, so those three are done. Now there's one circle left to draw. So I go back to my circle command. Down here, this one is 25.25 millimeters. We hit enter. And then we can start to align where it sits. All right, so vertically in line with this one. And then a dimension. I know the dimension from the center of that one directly above it to here. Line that up nice and neat. Just checking back here, 120. And there we go. So I've got the basics of those holes all lined up. The next thing I said I was going to do was draw a line around the outline of it. Now look, it goes something like that, almost like a big kite. Back to where I started, the green dot tells me I found an end point. Now there were some radiuses in these, so that's a fillet. That one was 55. Don't press enter. If you press enter, it turns it off. It says, oh, I'm finished. So this top one's 55. These two on the sides, now this needs to be, I think it was a radius of 25. Don't press enter because it turns it off. Select the line. There we go. That's 25. That is 25. And the one at the base is 30, just to trick things up a little bit. Down here, 30. Not locked in yet. Finished with my fillets. Now I want to take the center of each of these fillets and position them at the center of the relative hole. This coincident constraint, basically it says, take this point and match it to that point there. Okay, take this point and put it here. So it's starting to bring my shape together. This last one, there we go. Cheek plate is drawn. Keep all your dimensions. That's how the constraints are made. Okay, don't get rid of them. It looks a little bit messy here, but you won't see it when you extrude this part and actually give it some body. All right, so I'm finished with my sketch. Very happy with the shape. Zoom out a little bit and position it. And then I can extrude that shape. Look, that's the bit I want to extrude. The thickness is 12 millimeters. What did I just type? You need to change it. Double click on the icon and it'll bring that back up. 112. Very good. And hey, fixed. Not quite finished with this. At the moment, this is just given a default material. It could be anything. It could be Play-Doh, it could be concrete, it's a nondescript material. To give it a material, this one here, it says generic. If I use that drop down and I go looking for steel mild, it actually tells me in my drawing that it's mild steel, it gives it a mild steel finish. Material, base material. The next one over to the right is the type of finish it has. So we could go through and say, look, I want to paint it yellow. All right, so that's that. Saving it, I like to get people into the habit of going to File, Save As, just so in case you're modifying a part to use as something else, you don't accidentally save over your original and lose all of your hard work. So this one is part number 6, and this is a cheek plate, all in capitals. All right, and save. All right, first part of our sheave pulley complete. Okay, so tune in for the next video and we'll have a look at drawing a spacer. See you then.